First step, disconnect the battery. Second step, wait for 10 minutes. Listen to it. Make sure they are not punctured or leaked. Air leaked. Make sure they are not air leaked. Up. Pull that way. Put in your pocket. Put this one in your pocket or in safe place. In a safe, you can put it in a safe. Okay, the corrosion is still here. I haven't removed the corrosion yet, as you can see, but I'm going to show you on this second generation Toyota Prius high voltage battery where the number one module is located. Actually, the number one module is located just, can you see that the negative long cable where the terminal is going to be connected? So where the terminal is connected, this is going to be the module number one, following by 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 to the end 28. So I have removed all this brass bar plate, and as you can see they are highly corroded, plus the nuts, the sports nuts, and also have cleaned this post with this. And now I'm going to take the value of each module voltage before going to do a load test on them. So we are going to determine or find that which one is suitable for load test and which one is faulty and rubbish, needs to be changing without putting any effort to load test them. Okay, now I'm going to show you the each module voltage. So this is going to be the open circuit value that I'm going to show you here. Sometime you might see here negative sign with the measurement like 7.3, and then you will see minus 7.3. That's because I'm not over or swapping the lead of the multimeter. So it's not going to reach here. Done. Okay, this is module number one voltage. As you can see, it's minus 7.3. It's actually 7.3. Module number two, module number three, module number 4, five, 6, 7, 8. But I'm going to mark that 8 is bad. 9, 10, 7.4, 11, 7.2, 12, 7.4, 13, bath 6.5, 14, 7, bath 15, bath 16, 7.3, 17, bath 18, 7.4, 19, 7.3, 27, bath 20, module number 27 volt, bath 21, bath 22, 7.4, 23, bath 6.5, 24, 7.2, 25, 7.4, 26, 7.4, 27, 7.4, and 28, 7.3. So we got 1, 2, 3, 4, 5, 6, 7, 8 module faulty. So those 8 modules has to be replaced. And also here we are going to use this with this to remove corrosion from this plates and clean the modules posts or terminal nuts. So if you can just use 3 to 1 the ratio, so 3 to 1. So 3 portion to 1, 3 portion vinegar and 1 portion, this is the ratio, baking or bicarbonate of soda. Okay, I'll put approximately 250 milliliter. I think it's going to be milliliter, yeah, 250 milliliter of distilled white vinegar. Now I'm going to put Okay, the process has already started, as you can see, and now I'm going to add baking soda too. I'm going to put that much. And I'm going to leave that for approximately half an hour or 45 minutes. Okay, now I'm going to show you how much current I will be using to test the module for load test, or to load test the module. So as you can see, this is the bulb I will be using to test the module for a load test, and I'm going to show you that how much current will go through each module load test. So I'm going to apply, look, it's 4.40, it's going to be 4.4 amps that I will be testing or applying 4.4 amps of current to the module, that each module I'm going to load test. We got eight modules non-workable or faulty on this battery case, high voltage battery case. This is for the second generation, and now we have purchased a complete case of third generation, and if you want to do it, you cannot straight away swap the case of third generation or generation 3 with the second generation, and there are much differences. First, as you can see, the the service grip plug is located here on this side. If you stand straight to the face the battery case, and it's located here. This is the third generation that I'm talking about. And also terminal which is connected from the high voltage battery blocks to the junction box or to the relay contactor is just pushed and click type of a connector. As you can see, this is another difference. And also, if you can see, the positive cable of the high voltage battery is to this end, as you can see, that is here, and the negative one is going to be here, but and also this is completely different from the third generation. This is the second generation, and it's completely the opposite. As you can see, this is the negative terminal cable. As you can see, this is connected to the far end on the right hand side when you are faced toward the battery case. And as you can see, and the positive cable is connected here, as you can see. And this is I was wrong a little bit. As you can see, this is the positive cable, and this is the negative cable, as you can see. Wow. Let me so if I bring the entire case in the camera, as you can see, so cables are to the left side of the battery case when you are faced towards the battery case. But on generation 2 or second generation, so cables, battery cables are located on the right side when you are faced the battery case. And another difference, because this is the smart unit, is a bigger unit, as you can see, and the this junction box is completely different, and it looks to me simple. And also the service grip plug, as you can see, the connector are too close on generation 2. As you can see, the both pens are too close to each other, as you can see. And on third generation, let me show you there, the pen contacts are too wide. This is the third generation, and as you can see, the smart unit is too small, and that's the terminals of the two cables, which are push type. But here, let me show you. As you can see here, they are screwed to the junction box or the battery relay contactor, and the smart unit is too big. So we are going to just swap or transfer this blocks or modules to here. So we are going to use case the same, junction box the same, and just bring those modules and blocks. And also we are not going to use the cables and also the voltage sensing wires as well. We are going to use its original this terminal. So this is generation 3, and as you can see, that is the different. And as you can see, cables are located on this side, cables which connected to the junction box are located on the left hand side when you are faced to the battery case, when the junction box is located to the far end and also on this one the battery cable and sensing voltage sensing wire is located, or wires are located on the right hand side when you are faced the battery case, where the junctions but junction box is located to the far end. Another big differences between the battery pack of the third generation and second generation is that the third generation uses 3 temperature sensor, as you can see, 1, 2, 3 on top, maybe 1 underneath but not sure, as you can see. So the second generation only use 1 temperature sensor on top, as you can see, just 1 sensor. Let me show you that. As you can see, just 1 sensor on top, maybe 1 or 2 underneath. So on top there is only 1 temperature sensor used on generation 2 or second generation, but 3 temperature sensors are used on third generation. This is another differences between the 2 generations. Okay, this is generation 2 or second generation modules temperature sensor. There are actually three temperature sensor which goes underneath of the modules or the battery pack. So one goes on module number 1, and the second one, this one, goes from bottom to module number 14, and the other one goes to module number 28. So there are threes from threes. So there are 3 temperature sensors from the bottom or from underneath, and 1 from the top. So the location is module number 1, 14 and 28. But on this third generation, all temperature which are 3, and they go from the top of the battery. Okay, we have moved all modules from generation 3 or third generation. As you can see here, this is the third generation battery, high voltage battery case, and we transfer those modules all here to the second generation battery case, and these are the third or second generation, or the original high voltage battery modules. And now we are going to, as you can see, the modules are being charged. So because the charger leads were too short, so instead of charging individual module, I made blocks. So I'm going to, and that's going to shorten the charging period as well, and also save some time. So now I have made that 4 blocks, as you can see. 1 2 3 4, and the blocks are being charged. Once we have restored the charge capacity, then we are going to balance it, and also we are going to thoroughly clean this corrosion. So if you want to not this is the blocks which are being charged, temperature, as you can see, and also as you can see here. So when the module is getting full or excuse me, so as you can see, when the voltage of the block goes up, the current flow reduces. This one is full, so the voltage raised to 17.17 volt, and the time took was 116 minutes and 31 seconds, and the current was pumped into the block into 2 modules, was 5106 milliamps. This one is also full, so the voltage has gone up to 17.08 volt, and the time took 152 minutes and 48 seconds, and the current which was pumped into the modules in 2 modules were 4316 milliamps. Make sure this one is covered when you're taking the battery. Here now we have no voltage. So when the contactor relay is energized, then this 2 contactor is going to be closed. So when the contactor relay is energized by the 12 volt auxiliary battery, then these 2 contactors are going to be closed, and then we will have high voltage battery, full voltage here. Put everything back in, install the high voltage battery pack, put everything this panel, and let's see what is the truth time. So kill again and push the power button. It is still resetting. Maybe the battery, maybe the fault code needs to be cleared. With the battery pack replacement, as you can see, delta state of charge is 0. Previously it was 1.5. Okay, we replaced the high voltage battery pack, and we were approximately 90% sure, or maybe 100% sure, that this is going to be the problem. And so because we had the fault code P0A80, that the high voltage battery pack must be replaced, and also when we check the delta state of charge, it was 1.5%, and also one block or two block when we check the freeze frame data of the fault code, that was too low. And also when we remove the high voltage battery pack, and when we check the voltage, there were 8 modules which had voltage below 6 volts, below 7 volts. So then we were much sure, and also we promised the customer as well, when we change the high voltage battery pack, it's going to cure the problem. But unfortunately, when we install the battery, and when we try to start the engine, and the engine is acting like so, let me show you that. So if I now let me clear the fault code, and here this is just the new scanning report. If you can see here, there is no any fault code in the high voltage battery. As you can see, no fault code. And so if I scan that right now, let me turn the ignition on. So ignition is on. If I read fault code for you and say no fault code in high voltage battery, so anyway, but here is a we got here engine failed to start, this 2 fault codes now. And also we got here another fault code, this one, as you can see, it says P3190. So right now engine is again not going on ready mode, but this morning when I was going to bring the vehicle from outside to the garage, it was going on ready mode, and also then the high voltage battery and the motor generator 1 was trying to start the engine, but unfortunately it couldn't start the engine. And also here, so if I show you, so let me show you freeze frame data. So this is the current one, as you can see. So we got one history and one current. So if I retrieve the freeze frame data of the current one, and you might be able to see, I'm going to show you something. Look here, the important thing, I'm going to show you what is the important thing. So actually, this freeze frame data previously was 8 pages. Now it has reduced to 2 pages. Anyway, and the important thing is that so the motor generator 1 try to spin the engine for 13 seconds, and the engine revolution was 1280, and which the specification is 1300, which is matching the specification. So this tell us that there is no fault in the transmission unit or in the transmission itself. So because we have the engine revolution match the specification, and let me go back and being detail. So just hold on, because I'm going to scan this one again and see what's saying. So read fault code, and let me see this this, no, this is the same 2 pages, and just hold on. So anyway, I'm going to carry out a clear DTC function and see this time, because because of this fault that the vehicle is not going to ready mode. Let me see what is that for. Vehicle height, that's not important. So anyway, we have cleared the fault code. Now I'm going to turn the ignition off once again. So let's turn the ignition. I'm going to turn the vehicle onto ready mode. So let's see. Can you? Yeah, now look, the vehicle is trying to start. Look. Look, full code. The vehicle, the engine has turned off. So let me take the vehicle out of the ready mode, because I'm not going to draw too much current from the high voltage battery. Otherwise, if we draw too much current from the high voltage battery, then we will need to remove the high voltage battery pack and charge that on the bench, which we don't want to do that. Just so I'm going to turn the ignition on. If you want to turn the ignition on, only ignition on this Prius second generation, just turn the ignition on. Do not press the clutch or brake pedal.
So then the ignition will stay on, and then you can connect external charger to the auxiliary battery, to the 12-volt battery, and then so you can you know continue your diagnosis. So if I go back and I'm going to do the look, we got again 3-volt. Look here, as you can see, we don't have fault code again in the high voltage battery pack. We only got 2 in hybrid control system and 3 in engine control module or unit or PCM, whatever you call it. So let me see that one, this one. So as you can see, one is current and one is history. So if I enter that, and look, if I go for the freeze frame data, it's still the same. And as you can see, the engine revolution per minute was 1280. So if I go back, I'm going to go here and see the current one, this one. Read fault code. So as you can see, these fault codes are stored in the PCM or engine control unit as say poor engine power. So if I go to freeze frame data, yeah, this is the one. It has 8 pages. So if I show you the important things, so look, we don't have misfire. As you can see, we have no misfire at all, because this is cylinder 1, 2, 3 and 4. This is the freeze frame data of the P3190, and so look, the engine speed was 1277.25, and I'm going to show you ignition advance. Hold on. Misfire margin, misfire RPM, throttle, 8. Vehicle speed, no. Vehicle load, that much. Throttle. Let me show you something that I saw previously. Oh, it again, this is no good. So 7, 6, 5, 5. Let's go to for fuel level. Look, fuel level not empty. Fuel pump speed on. Fuel status. Fuel high voltage. Look, this is the target. That was important. I was looking for high voltage target engine speed 1300. So this is approximately matched on the real engine speed which was spinning by the motor generator 1 or high brake system. This is so everything here is okay. Now the second thing is that I'm going to check the fuel pump pressure. First I'm going to find the specific fuel pump pressure, the specification of the fuel pump which is located in the fuel tank or the fuel delivery pump. Check that one, and if that was okay, second we are going to check the spark, which whether the spark is coming to the spark plug or not. I did check the spark plugs. It was a little bit carbonized, but anyway they were not short, and also the resistance of the center electrode was within the spec. Then if we had spark coming to the spark plug, the next step is to check the compression, engine compression. So engine compression specification for this vehicle is, let me show you on the service manual. Look, compression pressure, normal pressure is 14 bar, as you can see, and the minimum pressure is 11 bar required. So maximum allowable pressure difference between cylinder is less than 1 bar, less than 1 bar. So this time, so first fuel pump pressure or fuel pressure, secondly spark plug spark, third compression.